Okay, so let's look at this same problem with drawing the blue and the yellow and figure out what's going on with it and how we're going to calculate the probabilities. Okay, so we know we have our bag with our 2 blues and our 2 yellows. So for the first draw, there are 2 out of 4 possibilities for a blue and 2 out of 4 possibilities for a yellow. So for each of these, the probability for the first draw, 2 over 4, reduces to 1/2. Okay, but now I should have added a space in here, but I didn't. Now we need to look at the new bag. Okay, so in here, before we do our second draw, the bag has been changed. For this one, if I pulled a blue, then I have a blue and I have 2 yellows. Whoops. And I have a document camera that wants to get knocked around. Down here, if I pull a yellow, then what I have left are 2 blues and a yellow. So for my second draw, I'm all done with this part. For my second draw, I'm looking at this bag. Now, the probability of drawing blue, there is 1 out of 3. The probability of drawing a yellow, well, there are 2 yellows out of the 3 possible. Down here, I've got 2 blues and a yellow, so the probability of drawing a blue, there are 2 blue out of the 3 possible. And finally, the yellow, we have 1 yellow out of the 3 possibilities, so this is 1/3. So all I need to do now is just multiply this out. 1/3, 1 times 1 is 1, 2 times 3 is 6. 1 times 2 is 2, 2 times 3 is 6. 1 times 2 is 2, 2 times 3 is 6. 1 over 6. Okay, now on the top page of the next page, it just shows what we did before, what we just did, and how that all worked. I'm having major document camera issues this morning. I apologize. Okay, so we've got our first draw and our second draw. So the probability of a blue and a blue is 1/6. A blue and a yellow is 1/3 or 2/6. A yellow and a blue is 1/3, which we had as 2/6, and a yellow is 1/6. Okay, so let's figure out the probability about player 1 and player 2. Well, we know that player 1 wins if both tiles match. That means a blue, blue, or a yellow, yellow. So here is our blue, blue. Here is our yellow, yellow. So we now have to find the probability of a blue, blue, or a yellow, yellow. And we do that the or we add. So the probability of A or B is the probability of A plus the probability of B. So the probability of BB, blue is 1/6, of yellow is 1/6. When I add those together, I add 1 plus 1 over 6, which becomes 2 over 6, and it reduces to 1/3, but again, you don't need to do that. Then player 2, if the tiles do not match. So that would be a blue-yellow or a yellow-blue. Okay. So the probability of a blue-yellow is 1/3. The probability of a yellow-blue is also 1/3. So this becomes 1 plus 1 over 3, which is 2/3. Okay, so player 1 winning has a probability of 1/3. Player 2 winning has a probability of 2/3. Do you think it's fair? No. The probability of player 2 winning is twice the probability of player 1 winning. Okay, so now let's see what happens when we do with replacement. Okay, so with replacement means that we're starting out with our 4 dots. We've got our 2 blues, our 2 yellows, but we are replacing them. So with replacement, means they are independent. Now let's show you why. Okay, so if we start out with 2 blues and 2 yellows, we've already done this on the first draw. We know there are 2 out of 4 for each of these, which reduces to 1/2, and again you can leave it as 2/4 if you want, it doesn't matter. But now let's look at the new bag. Okay, we're done with this one for right now, but we're going to look at the new one. Since I replaced them, it doesn't matter what I pick, because I'm putting it back. So the new bag is the same as the old bag. So now the probability of getting a blue for the second draw is still 2 out of 4, which becomes 1/2. 2 out of 4, which becomes 1/2. 2 out of 4, and 2 out of 4, and I forgot to write these down. Of course, those reduce to 1/2. So if I total these up now, 1/2 times 1/2 is 1/4, which means it's going to be 1/4 all the way down the line. Okay, so player 1 wins if the tiles match. So that would be blue, blue, or yellow, yellow. So the probability of blue, blue is 1/4 plus 1/4. This becomes 1 plus 1/4, which is 2/4, or 1/2. Player 2 wins if they don't match, which means that is a blue, yellow, or a yellow, blue. So the probability that player 2 wins is the probability of blue, yellow, or yellow, blue, which is the probability of blue, yellow plus the probability of yellow, blue. Well, I know that is 1/4 plus 1/4. I'm sure a lot of you can jump from here to here, but just to make sure. So based on the theoretical probabilities, which is what should happen, is game 2 a fair game? Yes. The probabilities for both players is the same. So that's the deal with replacement and without. If you're replacing it, you're not changing the game plan. You are just doing the experiment over so one doesn't have anything to do with the other. If you are changing the experiment, if you are changing what is in the bags, then that becomes a dependent event. Okay, here are some extra practice problems, and let's see, how am I doing on time? Let me go ahead and quit here, and then if you don't want to do the extra practice problems, that's fine. I'll start a new video. Okie doke.